Nicholas Ray to give our first lecture. He's a senior lecturer at the Institute for Environmental Sciences in the University of Geneva in Switzerland. He also heads up a unit in environmental modelling and geoprocessing, which is part of the United Nations Environment Programme. His academic work and his UNEP work is really focused at the moment on understanding how all the massive amount of environmental data that we are faced with can actually be used, processed, analysed and feed into the management of environmental issues. He's also part of a network of Christian evangelical scientists in Switzerland who meets annually to discuss issues arising from science and faith. So, Nicholas, over to you, the science of environmental changes.
Thank you very much, Hilary, for this introduction. Yeah. So, I'd like to look at some and only some of the changes that our planet and its inhabitants are facing today, and what could be the consequences of those changes in the future. And at the end, we also look at some of the solutions that have been proposed. So, let me really just start with this beautiful view from space of our home in the universe. Extremely dynamic system, highly interconnected natural world. Yet a system that can be altered by its inhabitants, that is altered currently at a global scale by human activity. So, this is a map showing that we are actually the biggest transformation agent now. This is a map from NASA showing the percentage of modification, alteration of in the various continents. And we humans have basically modified more than 50% of the planet. So you see the colors are related to the percentage of changes. So a lot of changes, of course, in Europe and Eastern US and other places. The only area that are somehow less untouched are zones like northern Canada, Siberia, Tibetan Plateau, Central Australia, Sahara, Amazonia, and so on. But really transformative agents. The oceans also have been, of course, and are still very much exploited, sometimes to the limit, and overexploited in many places as well. Of course, one of the reasons of these changes is the population of humans that has dramatically increased for decades. We had a population of about 3 billion in 1980. We are now more than 7 billion human on that planet, and the prediction is that by 2050 we should be around 9 billion people. So we're adding roughly the equivalent of Germany, 80 million people per year on the planet. And while it has also been estimated that by 2050 to feed 9 billion people we would need to have 70% more food will need to be produced than today. So with huge challenges on how we're going to do that, to achieve that. If we look a bit in the past at the temperature changes of the global temperature changes in our planet, this is a graph showing so these relative changes compared to today's temperature over the last 100,000 years, and you can see that these temperatures have changed quite a lot. This is due to various natural reasons, such as different cycles of the Earth due to orbital changes, angle of tilt of the Earth's axis, changes in solar irradiance, volcanoes also had an impact. But what you can see also is that in the last 10,000 years, so the so-called Holocene period, we had a fairly climate stability with not much changes in temperature that probably also enables humanity to flourish and to involve some of its cultural and technological system. Now the issue, of course, today is that this global temperature is on the rise. This is
summarizes so over the last about 100 years how the relative temperature is changing, and it has been increasing, and there has been no actually slowdown in temperature rise. There have been very recent studies, and one of them was published actually about 2 weeks ago, that looked again at all the data and corrected some artifacts on this temperature, and show that really there is no slowdown in temperature, that it's keep climbing. Now, of course, the worrying part of this climbing is what is going to happen in the future. And this is from the work of the IPCC, so the Intergovernmental Panel on Climate Change, which is this huge panel of worldwide scientists that are looking at this climate issue, and have issued their fifth assessment report in 2013 and 2014 with several scenarios for how the temperature and of course many other climatic factors are going to change in the future. So on that graph you see basically two of these several scenarios that are being built and proposed by IPCC. These scenarios are built upon different prediction on greenhouse gases emission, different policy that would not be applied, economic growth, etc. And you have basically the two kind of extreme scenario in the ranges that they're proposing. So in blue, you have a kind of low emission mitigation scenario, where everybody agrees to decrease a lot CO2 emission. And in red, you have kind of high emission scenario. And you can see that the temperature changes, the relative temperature changes would be somehow between about 2 degrees to 5 or even 6 degrees, which would have dramatic consequences. And it's even predicted that it could be a 30% chance of exceeding 6.4 degrees by 2100, which would again have dramatic consequences. Important to state that these temperature changes are not especially evenly distributed over the Earth. So this is a map showing again this observed change in surface temperature during the last century, and you can see that depending on where you are on the planet, these changes are quite different, and you have even some cooling in northern ocean as well. So the globe is warming. That's a fact. Do we have other indicators of this warming world? Well, we have many indicators that the world is warming. The glaciers are decreasing in size. Of course, the different temperature of the land and of the ocean. The snow cover is decreasing. The permafrost, which is the ice stuck into the ground in Siberia and other places, is retreating northward. Tree lines are shifting. Also, spring's coming earlier. Species range changes, we'll talk about that later. In the atmosphere, humidity is increasing, and many other factors. The sea level, also I'll come back to that later. The sea ice extent is decreasing as well. Ice sheets, ocean heat, so many indicators of a warming world. Now, one of the root causes of that is the increase of greenhouse gases in the atmosphere. So you have here some sketches of the increase in CO2 concentration, which is the main agent for the greenhouse gas effect. But you have other gases such as methane, nitrous oxide, and several of these so-called CFC, chlorofluorocarbons, that are kind of levering out because there have been this phasing out of the CFC that were in different products, and so the increase has been halved, but they are still in the atmosphere and still participating to the warming. So concentrating on this CO2 concentration in the atmosphere. It has been steadily increasing since many decades. And you see this kind of natural oscillation here that's seasonal oscillation due to photosynthesis during the summer period in northern hemisphere, where plants are absorbing CO2 and so yeah, this kind of shit, but it's increasing at a steady state. And I just indicated here the concentration, so this is expressed in parts per million, and the 350 parts per million is the somehow called safe level of CO2 in the atmosphere in order to stay below kind of 2-degree warming in the future. So this is really the aim of many policy, and actually many are saying that it's already too low. We won't achieve that even with the best policy available. So, but this is the goal that the policy should aim at, decreasing CO2 so that it goes below this 350 ppm concentration. That was the concentration in last month. I looked at the NOAA data. So May 2015 was the highest on record. Probably June 2015 is very likely higher than it was in May. So the greenhouse effect, probably you all know about it, but just to recap quickly. So the solar irradiation is some of it is reflected by the Earth and the atmosphere, but some of it is absorbed by Earth's surface and warms it. And then some of the infrared radiation that is emitted by Earth's surface is captured by the atmosphere and is emitted back to the Earth and participate to this warming. A very important effect. Without this greenhouse effect, the global temperature of the Earth would be around minus 15 degrees, so no life possible on the planet, on the surface of the planet. What are the sources of this CO2 emission? You have here a graph showing these various sources since 1850. So coal was of course important for a long time, but oil picked up relatively quickly and is relatively equal to coal now in terms of CO2 emission. This is in million metric tons. Gas as well, and the cement industry also is participating as well to that. All these emissions here actually account for about 80% of the total emission of carbon from human activities. The remaining 20% are actually linked to land use changes like deforestation, cutting down forests, and others. What are the sources of emission? Well, the energy sector accounts for about a third of these emissions, but you also have agriculture and forest and other land use, as I said, industry, transport for 14%, and again, this building sector account for a small percentage. This is an interesting, actually, short movie that has been recently released by NASA, even though it's based on 2006 CO2 data. And I think it's when I first see that, it was a great, quite a dramatic way of seeing how kind of local emissions are actually have a global impact due to the atmospheric currents. This CO2 is basically moving around, as you can see, and so the reddier, the larger the emissions, so you can somehow see that in the US, in Europe, and in China, of course, now we have a lot of these emissions. This is during the kind of winter months, but if I move a bit to the summer months, these concentrations are decreasing because photosynthesis is taking some of the CO2, and so you see less red color on here. You can also see this kind of white plumes from stemming out of Africa and other places. This is carbon monoxide from different type of fires. This is another pollutant, and you can see also this dramatic emissions of carbon monoxide from different places. Very nice movie, you can get it at the NASA URL, and it's commented, there is a comment with that movie as well, quite interesting. Of course, the other big impact, as I said, that is also a cause of this CO2 emission is deforestation. Deforestation accounts today, as I said, for about 20% of this CO2 emission worldwide. This is a map of the Borneo Islands, where Borneo has seen its forest decreasing by 30% in the last 30 years, to be replaced, part of it, by palm tree plantations and others, and of course with dramatic impacts on biodiversity on this island, on the orangutan, for example, that live in Borneo, and other effects on biodiversity. Deforestations at the global scale accounts, it's about 13 million hectares per year. And maybe contrary to what we might have seen in the news, it's not, deforestation is not decreasing. Actually, there's been a recent study in May 2015 in Geophysical Research Letters that have looked at a lot of data from 1990 to 2010, and that actually arrived to the conclusion that this deforestation has accelerated. And you see here on those maps in the countries with the with the largest forests in the world, you can see the kind of it's the net acceleration, yearly acceleration of deforestation. So many of these countries have positive net accelerations. Just a few of them are decelerating. And if you take into account the full period, so the 20 years between 1990 and 2010, you have a 62 acceleration in net deforestation during that period. Deforestation is a view from space, can be also quite dramatic. I'll just show here just two examples taken from one of the UNEP publication called One Planet, Many People. So it's an atlas of changing environment with a lot of case studies, and you can access that on the web and see all these examples. This is the Iguazu Fall, somewhere here between Argentina and Brazil. So that was back in 1973, and this is that picture was taken in 2003. So you can see the dramatic changes in land use, and actually different changes in Paraguay compared to Argentina between 73 and 2003. Another example here is in Bolivia. Again, this picture is 1975, and you have here the same area in 2003 with again dramatic changes, agriculture and other changes. You have a nice resource, a nice kind of big project called Forest Watch that is looking, try to look at real-time or near real-time deforestation in the world with using many different techniques, and it's quite dramatic also to see these changes, and you can see how that changes in the last decades for each year. So I encourage you to have a look at these sites and have a look at the various variables that you can graphically show there. It's quite interesting. Deforestation so has an impact on this CO2 emission, biodiversity, but has also impacts on other type of impacts, and one of them is that forests protect for landslide susceptibility, and in many places now in the world you have big problems due to deforestation, and this is just one of kind of dramatic example of a landslide that really cuts the road, which is due to the deforestation on the hill on top of it. So deforestation, as I said, has an impact also on biodiversity. So biodiversity loss is another major change that we are facing. Many reasons for this biodiversity loss. So habitat loss, of course, is one of the major ones. Climate change, we're starting really to see the effect of climate changes on the range of species that are shifting on many aspects of the ecology of species. Invasive species as well, poaching, pollution, of course, and sustainable fishing and hunting are also the cause. And there's also been a recent article looking at the rate of biodiversity loss at the global scale. And the conclusion of that article was that the rate of extinction is currently between 10 and 100 larger than it would be under normal kind of geological circumstances. And that's not even accounting for climate changes in this calculation. So really, we are really facing very fast species loss, and human habitat degradation is the main factor of that. And of course, habitat degradation is linked to the crops that we need to grow, that are also used to feed animals that we eat. And an interesting graph that I found to illustrate that is this one. This graph portrays the weight, so the mass of humans and other mammals. So each of these square is 1 million tons. So in the middle, this dark square are the weight of humanity, if you want. And all around here, this kind of lighter squares are the weight of cattle, pigs, goats, sheep, and horses. Just so that you realize a bit the relative weight of all this. And the green square are the wild animals. And you have the elephants, which are just this small square here. Another really foreseen effects of climate changes, and that's been discussed in the last IPCC report, is how this will impact the speed at which many species can adapt to the climate changes. On that graph, you see the maximum speed at which species can move, so from 0 to 100 kilometers per decade. And you see here different types of species considered, so trees, carnivores, mammals, primates, etc. So of course there is a range of speed depending on the species, and for example the carnivorous mammals can move very fast compared to others. But here you again have the different scenario, climate change scenario from IPCC, so from the kind of low emission to the higher emission. And so you can see that actually, and in this scenario, that's the speed at which climate change will occur. And so you can see that for many of these scenarios, many species won't be able to move fast enough to cope with their changing environment. And so we are facing also massive species loss due to that, and especially, of course, if we are rather on the right side of this type of changes. Another changes, of course, and is linked to water. Water is, of course, another very important element of climate changes, water concentration in the atmosphere. Here you have a prediction map of the changes of water quantity in the coming, I think by 2050, with a 2-degree scenario above what we had in the last 30 years. This is somehow a kind of complicated legend, but basically when it's red, that means they will face much less water, and when it's bluish, that means we will face more water. And so you first see that it really depends on where you live, and also that in many places where they already have issue with water and lack of water, they will have even more in the future. And in many places where they have problems with too much water, floods, and like in Bangladesh and other places, they might be facing even worse conditions in the future. There are dramatic examples of overconsumption of water, and of course you probably all know the Aral Sea example between Kazakhstan and Uzbekistan, initially 66,000 square kilometers, and then due to the cotton industry that has absorbed this water, this big lake has shrunk a lot and is now about, but it remains about between 10 and 20%, I guess, of its original surface. So a dramatic change of water availability. Another example is more urban example is Las Vegas. This is a picture 1973, in 2000, and in 2006, and finally in 2013. So dramatic increase of the city with a huge consumption of water for various reasons, very, very large consumptions. The liquid water is not the only resources. Of course, ice loss is, we can observe that. This is a graph showing how the quantity of ice is decreasing, both in the Greenlands and Antarctica. And in 2012, we had a record, the lowest on record surface of Greenland. That was basically half what it was 20 or 30 years ago. So dramatic loss in these polar ice sheets that also have an impact on sea level rise. Sea level rise, this is the model again from IPCC on about how the sea level will change in the coming decades, again with these two extreme scenarios. So this is expressed in meters. So the red scenario predict that it could be up to 1 meter rise by the year 2100. So again, dramatic impacts on coastline aquifers, beach erosions, and displacement of people, of course, that will be affected. The estimation is that a 1 meter rise will affect about 100 million people that will need to move and to find other places to live. The higher concentration of CO2 also impact ocean acidification because the ocean is absorbing some of the CO2, which decrease the pH of the ocean, and that has an impact also on the ecosystem and animals that are building their shells and then their exoskeleton. And also to show that this change of pH is not uniformly distributed over the Earth, but you have also differences that are due to many reasons of the oceanic circulation. I come back to resource depletion. There are many depletion of this water and biodiversity, but there are others that are maybe less known and that have an impact. And I just wanted to show you one of these, and this is sand. Sand, the global use of sand is about 30 billion tons a year. Of course, it's used in the building industry to make concrete, and it's used more and more, of course, for our cities. So 30 billion tons a year, it's enough to actually build a wall around the Earth of 27 meters high and 27 meters width. So just to give you an idea. And the issue with sand, you might say, well, we have enough sand, we have the Sahara, we have, but actually you cannot use the sand from deserts because they are the sand grains are too round due to the wind and the way they move. And so it doesn't hold when you make concrete. So you really need sand from the bottom floor of the ocean or from beaches. You cannot use sand from deserts. And that has huge consequences. There is now you can say a kind of global mafia of finding sand, and there are places where literally overnight people are coming and are stealing the beach. They are just taking all the sand of the beach and selling that to many places. And that has dramatic consequences on the ecosystems, on beach erosions, on fisheries for local peoples, and that's really a problem. This is Dubai in 2001, Dubai in 2011, so you might have heard about these artificial islands that they've built. They use 1.2 billion tons of sand to do that, essentially coming from Australia and other places. So you can imagine the cost and all the effect that importing that sand is causing, and many of these islands have not been sold. Singapore, another example, in 73, 89, 2009, 2013, they've expanded their territory by 25% by also importing sand from Australia and other places. And so it's also a dramatic impact. Disasters is of course another consequences, and I don't have time to go through that, the change in disasters. But let me just quickly talk about one of the disasters that our team at UNEP have been looking at, which are cyclones. My colleagues have been looking at 30 years of cyclone track history, so these are the tracks of the cyclones, looking at how the cyclones have changed over 30 years. And the output is that actually cyclones have and will not increase in frequency, but they will increase in intensity over the next decades. And again, that will have also dramatic consequences on the populations that will not be prepared enough to getting even worse cyclones that they're having now. Another thing, and I couldn't not show it because we're experiencing this heat wave now in Geneva, is the exposure to extreme heat, which is actually on the rise. It's another recent paper in Nature Climate Change, and last May was published, that really was able to show that extreme heat is on the rise, and that's their forecast for the future. This is expressed in a kind of particular units here. Those are average annual person days, so that's the number of days where the temperature is higher than 35 degrees, times the number of people that are living in those places. And so these are the extra person days that they will be facing in the period 2040 to 2070, and that's expressed in billions of these person days. So probably a lot of problems in the future are linked to these heats, and especially in cities, of course. That problem and many other are linked to health problems. And climate changes will actually undermine the environmental determinants of health. A lot of study by the World Health Organizations have and are looking at those issues. And for example, climate change, of course, will affect the water quality and the quantity. There are predictions that would contribute to a doubling of people living in water-stressed basins by 2050. Of course, everything is linked to food security. In many African countries, the yields from agriculture may halve by 2020. Everything that is linked to infectious disease, mosquito range will actually go northward, and so malaria and dengue will affect many more people. It's estimated that 170 million increased extra population will be affected by 2030, and 2 billion for dengue by 2080. That's the estimation from WHO. And of course, the protection from disasters, as I said, protection from coastal flooding might increase a lot, extreme drought, etc. Again, health impacts will be unfairly distributed. This is a so-called anamorphous map. So the countries have been inflated related to a certain variable, which in that case is the emission of CO2. But here you have the same kind of anamorphous map of the per capita mortality due to climate change. And you can see that, of course, Africa will be heavily impacted by those changes. So, solutions, what can we do, what is being done? Of course, a lot of mitigation measures are being tried, are being done. More efficient, so mitigation measures are intervention to decrease greenhouse gases emissions or to increase the sinks where gases are absorbed. So more efficient use of energy, greater use of low carbon and no carbon energy, and all this technology exists today. I mean, we have this technology, we know how to do that. Improve carbon sinks, either through reducing deforestation, improve forest management, bioenergy, and all this. And of course, all the lifestyle and behavioral changes that we will have to do, and you know all of them, buying efficient cars and appliances, green electricity, energy efficient homes, recycling, eating less meat, all this are measures, mitigation measures that we will have to do, and that's really the trickiest part, how people are ready and willing to change their behavior. So some people might say, well, it's too expensive to do all this. So in terms of economic term, we cannot do that. Well, actually, there's been a study, or many studies, showing what would be the cost at the global scale of climate action versus climate inaction. And here, so that's expressed in trillion dollars, so thousands of billions of dollars. The green here is the policy cost. Of course, to implement big mitigation measure, it has a cost, estimated at about $4 trillion. This is the cost of the damages from climate change by 2100. So the total cost of action would be that. And that's the estimated cost by 2,200. But those are the costs without climate action by 2,100. And you can see that basically it has been shown many times that the cost of inaction will be much higher than the cost of action now. And you might know that later this year there will be this COP21, the Paris Climate Conference in France, where actually for the first time in over 20 years of UN negotiation, there will be an aim to achieve a legally binding and universal agreement on climate, with the aim to keep global warming below these 2 degrees. So a lot of hope about this conference. A lot of people saying that they won't succeed. And one of the reasons that, well, last year China, India, and the US say that they will not ratify any treaty that will commit them legally to reduce CO2 emissions. So you see that it's really, it's a policy issue, it's a political issue of whether we want to move and to apply this legally binding kind of global policy, and that's a big problem. On the side of adaptation, of course, of mitigation, we have to adapt already, and there's a lot of adaptation that is occurring, and we'll have to increase that in the future. So those are slides from IPCC, planting mangrove tree to kind of counteract effects of sea level rise. Many other defense against sea level rises or floods. This is another one to try to reduce urban heat islands. So many other adaptation measures, water resource management, adaptation to agriculture, but it's becoming increasingly clear that adaptation must start now in many places and act quickly. But for some people, this is not enough. We won't succeed, and so some people are suggesting so-called geo-engineering approaches. Geoengineering is the deliberate large-scale manipulation of the planetary environment to counteract anthropogenic climate change. There are two main approaches in geoengineering. First is so-called carbon dioxide removal, where you try to have a solution that will cut the amount of CO2 in the atmosphere. But usually those are solutions that work slowly to reduce global temperature. And you have so-called solar radiation management techniques, where you aim at reducing the amount of solar energy that is reaching the Earth. And usually these techniques act quickly. This is a map. I don't know if you can see very well the text that somehow summarizes the various approaches that have been suggested for geoengineering. So it starts from various ways of getting the CO2, the carbons, and then putting that CO2 to the ground or to deep ocean aquifers and others. Genetically modified plants that will get the CO2 much faster. Wrapping of the glacier. There's been some field work on that with coating to decrease the loss of glacier. Sulfur aerosol from aircraft. We'll talk about that later. And then other ways. For example, on the right, on the top right end, there's been suggestion that one could send 50,000 mirrors in space, each of them 100 kilometers in diameter, and to actually reflect some of the sun irradiance. And that they've calculated that would actually counter half the doubling of the CO2. If it's larger than 100 kilometers, this mirror has to be made on the moon in order to be launched. And that has also been suggested that probably won't happen. Iron fertilization of the ocean was also a technique that I guess is still speaking about, actually to enrich the ocean and to have organisms taking this CO2 down to the bottom floor. And so all these different techniques have still been studied in terms of their affordability, their effectiveness, but also the risk that are associated to them. And there are huge risks associated to these global kind of geoengineering approaches. And let me just talk about one of these approaches that is, I guess, one of these approaches that is considered seriously by many people. It's spraying sulfate particle in the atmosphere. Because we realize that that's the same thing that happens when there is a large volcanic eruptions, a lot of sulfur dioxide in the atmosphere. And the Mount Pinatubo, for example, in 1990s, we had this, and that translated into a global cooling of the planet during the following years. And so people are suggesting that we could artificially spray sulfur particles in the atmosphere to cool down the Earth. The pros is that it's relatively cheap and easy to implement. Will have nearly immediate effect, because 1 ton of sulfur dioxide would cancel out the effect of 30,000 tons of CO2. And the cost would be about 10 billion per year, so relatively cheap. Of course, there's a lot of concern about that. It would do nothing with ocean acidification, would destroy the ozone layer, many other problems with carbon emissions. You would need to continually replace this particle, so there would be again ozone depletion, acid rain. And I think the big issue is that if this spraying was halted due for example, to any global financial crisis, warfare, pandemics, whatever, this particle would be washed out very quickly, and the global temperature would somehow skyrocket very fast. And then humanity would probably be facing two catastrophes at the same time. One of these and a very fast global increase of temperature. So the huge concern about that. And there are some ethical concerns about geoengineering, and many of them. Of course, the first one is that it does not address the core of the climate change issue, which is basically decreasing curbing emissions in the first place. It inevitably lessens the political will to begin reducing these CO2 emissions. One country or a club of rich people could decide actually unilaterally to start large-scale experiments of that kind, and so people are very worried about that and are trying to have global policy in place to avoid that. And yeah, you can argue that it's inherently unethical to decide for all humanity and generations to come how to change the planet, because we would be committing our children to follow up with our choices and to continue this geoengineering approaches. And finally, the enormous cost of doing research and implementing this geoengineering could rather be used for other things, like implementing clean energy solutions. So, wrapping up my presentation, so we've seen all these possible outcome, access to water, loss of biodiversity, extension of epidemics, all this. The issue is that they have a disproportionate impact upon the most impoverished parts of the world. On the other side, we have the emissions of greenhouse gases, overconsumption, resource depletion, pollution and waste, that have a disproportionate source from the wealthiest part of the world. So we really have here a problem of justice and equity. I think that's at the center of the debate, and that's very important to remember. And again, this map shows the CO2 emissions on the upper part and the vulnerability to climate change. And you can see how this is quite unfairly distributed. So, final slide, I guess, from a Christian perspective, also we have a lot to learn and to apply. First, we are asked, I guess, and the ministry of Jesus is showing us that we have to care for the weakest and the most vulnerable individuals among us. We also asked to care for the creation, for its biodiversities, for all the species. Humans have a special place in the creation order, and therefore they have a special responsibility towards the other species and toward the environment. And of course, there is all this issue of caring for the future generation, for our children, and that I think we are asked also to care a lot about this future generation, and that's really part of the action that we should be having. Some Christian might say, well, but God, wouldn't let that horrible things happen at this global scale, where I guess we are responsible for our actions, and a global scale disaster could really happen. Also, some Christian and other would say that, well, we are anyway, in the end time. Jesus is coming soon, so why should I bother with all this thing that I have to do because the end of time are near? Well, I guess Paul, when he's telling the Thessalonians, and I'm quoting here Catherine Ivo, which is one of the lead Christian climatologists, who is somehow rephrasing what is found in Thessalonian. I've heard that you've been quitting your job, you've been laying around and doing nothing because you think that Christ is returning and the world is ending. Well, Paul serves up a rebuke and basically say that you have to care for others and do what you can to make the world a better place, because nobody knows when that's going to happen. And with that, I finished with a nice slide, because there were too many depressing ones in my head.
Do we have some questions? Yes.
I'm from America.
This is Martha. Oh. I'm from America, and sadly there are several climate deniers, and you know, amazing coincidence, the politicians that are climate deniers come from coal-producing states. There are actually even politicians who have outlawed the use of climate change by the people who work for the state. It's so embarrassing. At any rate, I'm wondering, where in the world do they get their science? Because it's so obvious from the largest perspective for most of us that it's real. So where do they get their science to say that climate change isn't happening?
Well,
Make it up.
I guess the problem with, I haven't touched, actually I have a slide on that, but they're cherry picking a few things where you could, they're really cherry picking a few things to show things, but then usually, I mean, a lot of what they are putting forward as science, from my understanding, because I'm not a climatologist, but I understand that from my climatologist that they can deduce that easily. I mean that they take sometimes different type of trends and things. So the science is usually not right, and sometimes they cherry pick things that are a bit different in some places, and there are uncertainty linked to that. So, but that's the science really is quite bad. But let me just actually I prepared just a slide on denial. I knew that there would be questions, and I'm just here looking at the various types of positions for the skeptics, and you can have a look at it. But it's clear to me, and I bought a nice small book at the library yesterday on skepticism. I read it last night, and it's really good. You should, and that's where I took that. So that's the book, and they explained quite well actually that the core of the denial is usually based on political motive, on fame, on economic, of course, motive, and the oil industry is behind a lot of institutions that are promoting this denial. And there is a huge consensus, scientific consensus, on the anthropogenic effect of CO2 emissions. So, but I know that it's, especially in the States, that it's a big problem.
Well, can we just take other questions first?
Well,
I'm
okay, I'm just very calm.
Okay, very quickly then, three more.
I don't know that much about it, but there was something called the the Ice Age. Europe went through a period of 500 years where it got suddenly colder and suddenly warmer. And nobody knows why it started, and nobody knows why it ended. So I don't know if this is related to anything. If you read about Robin Hood and Sherwood Forest, not so far from here, they slept outside in the forest. You sleep outside in the forest now. In the winter, you'll freeze to death. So I'm not sure whether everything is absolutely so clear.
Yes, there has been such a period. I was trying to find out. And I think that was quite well explained with the release of some kind of sulfate, some kind of I think it was sulfate dioxide and other pollutant in the atmosphere from various reasons that were actually cooling a bit down the global temperature in Europe. But I can't remember right now exactly what it was. But there was a clear scientific explanation for that. If you let me look for it and I come back to that in the session tonight, I will answer that question.
Is there a point in the future where it will be said there is no way back? You know, it's going to go inexorably worse and worse and worse. So there's not a cut-off point. We can't do anything at all.
Well, some scientists believe that it will already pass this point, but I would say that many scientists are worried that at one point we may reach so-called tipping point, where there will be a dramatic, sudden, or quite fast global changes. It could be, for example, with the change of the thermo-haline circulation of the oceans that would dramatically change the climate. So probably if we are close to one of these tipping points, it's very difficult to say when they will happen, but some, many predictions of that. Some say it could happen very quickly, some say it's, a few 200 years in the future. But probably when we'll have reached such a point that will be fairly clear that we have reached a tipping point and there is no way back, at least in a human time frame. Of course, if you look millions of years in the future, the Earth will recover, of course, from itself. But yeah, so that's linked to this tipping points issue.
Okay, lots of hands. Roger, and then Kevin.
Thank you. Just to share, is this working? Hello.
You have to hold close.
Just to share a little something from the Philippines on the typhoon situation that you mentioned. I've lived there for 36 years, and as you say from your model, the numbers of typhoons per year have not really changed very much. So it's about 19 to 21 that we get every year. The intensity has tended to increase, but what has really changed is that the period of the year, which used to be from June to November, has now widened. So you could get a typhoon or a severe storm in almost any month. Even more worrying, the geographic spread has increased. So down in the southern Visayas and in Mindanao, which is the south of the Philippines, which never really got typhoons before, now they do. And what that has done, talking about irreversibility, for example, in Mindanao has some of the best sites in the world for farming seaweeds. Because of the lack of big rainfall and lack of runoff turbidity from the land, these were the world's best sites for farming seaweeds, which is a multi-billion industry, employing lots of poor people. And now those sites are no longer as good as they were. And so people are not going to risk putting money and investment into growing things where the risk has really increased, and it could be that some of those sites are really no longer worth even considering. So these are changes from typhoon behavior, let's put it that way, which are having almost immediate effects.
Thanks for that.
Kevin, can you check when you hold the microphone that you don't accidentally put it on mute? Because I think that's what the problem has been a bit.
So in conveying this message, that we need to do something, have you found any resistance coming from developing nations? Because from where I come from in Malaysia, we find there is another barrier that needs to be overcome, which is that there is this attitude, among some politicians as well, that this whole idea of environmental care and all these things is another form of Western colonialism and Western propaganda. Now that you've burnt all your coal and chopped down all your trees, now you're trying to stop us from growing by doing the same thing. I mean, we find that, in my own experience, that is another barrier that some of us have to deal with in my country and some developing countries. So, can you comment on that?
Well, I haven't myself spoken to many international audience about that, so I cannot tell you from my experience. But of course, there are a lot of nation groups that are just or feel that they're not concerned. But nowadays, it's a bit difficult not to be concerned because you can really see the effect in many parts of the world. And depending on where you are from, you might be, of course, less affected. I mean, in Switzerland, where I live, you probably won't be really affected by freshwater availability, even though our glacier will probably vanish and will have huge impact on also on the ski industry, because many of the stations of ski resorts will be lying below the snow line, and they'll have to close. But so I guess, well, of course, you find this at least for many reasons, but more and more it will be quite obvious in many countries that the effects are there, and you will have to do something.
Let's go over here to Francis, outside, also speaking from a global south perspective.
Thank you very much.
Yeah, but
Maybe if I stand, you'll be
But
able to
here,
Yeah, thank you very much, first of all, to the Faraday Institute that really have this topic in discussion, such a meeting, because really shows a positive movement. And I was talking to my brother and saying, one, there are about 40 climate change models, scientifically speaking, some which don't agree with the others. And some politicians have used that actually say there is no climate change, or rather it should be called climate variability, which is normal. But you know, the bigger question is whether we should start saying there is climate change model 1 disagreeing with 2, rather than taking action. That is one weakness of science. Sometimes it takes
too long to
design a bridge until all the people are falling in the water. And we must agree with that. And people like Senator Marco in the USA has
really been against this, even up to stopping ratification of some of these agreements. And we know that some of the countries in Africa where I work have definitely taken very positive steps. The presentation which he has made here, it is so real, we see it, and we see that people are central in determining what happens, and especially also the mitigation, which is, I think, what he speaking about. And in terms of the reading scripture, Isaiah 24 verse 5 is very clear. It shows us that most of what we see in nature has been degraded and appreciated by the action of man. God has put us central in managing the resource, though many people and even many scientists will say it's not caused by man.
But Isaiah 24 verse 5 is
very clear, putting human action central to this. And at WaterAid, where I work, we have definitely now started working out experiments and giving people simple examples to be able to understand the environment. As much as the international disagreements on this, we have weather stations that are manned by users. We have
people who have wells that actually do study groundwater, and these are located in
very different places, and you can very easily see the reducing groundwater.
In some
Places where there is irrigation, you're losing
about 2.5 meters per year. That is very dangerous. So it's once
we give this knowledge to
people to be able to understand the kind of effect you can
have on our own environment, it is the only way we can empower people to come back with action
and ask for change. And for me, see this as
as
the
the
place of
a Christian leader. So those are some actions we've done.
I've also read in the
With
US
where
there were disagreements
on this temperature change over time, because many weather stations were located in places where buildings were erected at some time, and therefore there was this discussion that where there is a building, there is a disruption in the ability of a weather station to function properly.
Shall we let Nicholas address some of these?
Thank you very much.
Oh, I don't know if I can address that. Thanks for this this insight. I know that groundwater is really a problem in many places in Africa and other places, and sea level rises will also have an impact on these coastline aquifers, a huge impact also on some populations. So, yeah, thanks for that.
So it's not really a question, it's a very short comment. I mean, I think central to the whole of government policy has been a notion of competition. We look at every budget that's ever done by a politician, it always says we've got to become more competitive, we've got to be able to outcompete our neighbours. You look at any political system, and yet that's not the central motif that we need. It needs to be more about collaboration and cooperation. And I think that is equally a much more fundamental thing that is going to make societies work. And so somehow that central idea needs to be changed.
Let's go right to the back now again.
For Christians who are concerned about this issue, do you think it's better that we invest our time in campaigning and political action, or is it more important that we actually make personal lifestyle changes?
I think both are quite important. I mean, if we Christians cannot show the way, I mean, yeah, that's really of concern. I mean, it's a battle also for me every day. I have to, how can I really make a change? But I guess it's important to campaign about that, probably not campaign, but try to involve people in conversation. And of course, in our churches, you might encounter fellow Christians that are more on the kind of denial side, and it's important just to discuss with them and to show them, that's the reality. So I guess both are very important.
Okay, we'll go here, and we'll go over to Samuel.
Some have suggested that much environmental damage that has led to climate change has Christian roots in a wrong understanding of Genesis, where it says humans are to have dominion over the earth, which has led to an attitude for centuries that humans are against nature and to dominate nature. And the proper understanding of that verb I understand in Genesis is that it is more to cultivate the earth. So I'm just wondering, it seems to me that perhaps a distinctive Christian response to all this is to have an attitude of repentance and mourning over the damage that Christian thought has done that has led to a lot of the problems that we're facing.
Samuel.
Thank you for your excellent presentation and awareing us about what is happening. When we talk about the global warming, and we have seen that most of the underdeveloped countries are being, affected by the global climate change. Now, I want to ask you what the higher level people are doing, bodies are involved, like in helping these countries who have been affected a lot with this.
Well, I guess there's two answers to that. The IPCC, and I mentioned this climate conference at the end of the year, where really they want to try to achieve global policy on CO2 reduction, on decarbonizing our population, global population, and so that's the primary aim, and without that, it would be very difficult to help the nations that will suffer most from climate change. But then, of course, there are many adaptation measures that are founded, but of course not as much that we need to have. But many developing countries now are seeing the effects of that, and there are a lot of UN bodies that are starting some huge project on helping those countries to adapt. But again, I guess the primary concern and aim is really to achieve a decrease in those CO2 emissions. And that's a policy, that's a political issue. And again, with the major emissions coming from the US and China and Europe, and India and others that do not want to hear about committing to that, to economic reasons. There are ways to really worry about if this can be achieved. So, let's see, but that's the answer I can give you.
Okay, I think this will be the last question. Rosa? No, it's Rosa. It's Rosa. Hold the microphone close to you, please.
My question is, have you found any relationship with environmental change and earthquake? The reason I'm asking this question, in the Himalayan region of Nepal, Sikkim, the common folklore is that there has been large-scale deforestation, which well explains the mudslides and the landslides. And they say that all these sinful human activities are kind of related, although we may not be able to explain. And Gandhi said in 20s that sinful human activity is related to natural disaster, quoting from scriptures. So I was wondering whether there would be any remote connection about climate change, human activity, and things like earthquake, which we can't predict. Thank you.
Yeah. Good question. I guess regarding earthquake, there is no firm scientific answer on that. But there are hints that indeed they could be linked in some places with deforestation, but also with some of the type of resource extraction, like gas fracking and other things, different kind of new ways to extract gas and other resources in the soil. That been shown, and the suspicion that they have been linked to our increased earthquake activities. But I guess there's no definitive answer, but yeah.
Okay, on that note, let's thank us for a very informative and challenging